So I want to do a little video on, and get this to focus, on like aerodynamics and fluid mechanics stuff. So it's like, why is this nose more efficient on an object than just this flat piece? And how much more efficient is it? Right? Is this nose more efficient, or is like this nose more efficient? So is the rounded nose more efficient, or is the pointed nose more efficient? So things like this. So you think like you just have a streamline of just air coming in like this. So if you analyze this separately, what you have is you have just a flat piece like this, and then you have a force that is striking the piece in the direction like this. Now, if I have this piece just in the air, what will happen is this end will rotate around like this, and this piece will also move in a direction like this. Right, so the amount of energy contained in the streamline is the same as this streamline here. But if I strike this streamline here, the entirety of the force is directed back in this way. If I strike the streamline like this, some of the force is directed because of this rotation. Some of the energy is translated into a rotational energy that doesn't obstruct the motion of the object. Right. So if you have a conservation of energy, where you have 1/2 mv squared plus 1/2 I omega squared is equal to the initial, so this is the initial here, right? So this is the initial motion. This is the initial motion, and then this is after the reaction. So this omega indicates rotational velocity, right? Omega indicates rotational velocity. Okay, so if you just look at this equation, just mathematically, if there is rotation, then some of the energy must be transferred into this omega, 1/2 I omega squared. So there's less energy left over for the horizontal motion of the object. Right. So we can do an example of this. If I come and I strike the object up here, you can see that it's rotating as I'm pushing it up, and it's also moving in this direction. So what we also have is we have a component of the reaction force. The reaction force is something like this. All right. So this is the force that you need to balance this, to balance the rotation, and also to balance this movement can be shown here. And because this force can be divided into two separate components, I'll do the components as a dotted line. Like that. There is a component of force that is perpendicular to the motion of the rocket. Therefore, it cannot decelerate the object. So the purpose of this nose is to transfer some of the energy in directions that are perpendicular to the motion. And that's the purpose, right? So if I'm, if I'm striking here, you can see there's a rotation. So try to just go straight line. See the rotation? So the energy is being transferred into motion in this direction. Right. So then if I have it like this, obviously, all of the energy is being transferred this way. Right? So if I have it like this, it's being pushed this way across. So it's not decelerating the motion of the object. So that's the purpose of the nose. Like some people you kind of think like if you have the nose, what the purpose is to like part the water or something, but that's not the reality. Okay, the reality is if I have a nose like this, the amount of area that is being struck by the air is equivalent. See, the area that's where the contact is equivalent regardless of how pointy the object is. Right? So here we have this is the cross section of the contact. So if I take away this cone, the cross section of the contact is the same. Right? So like if I have something like this, where I can draw a lot, the amount of air that is hitting this object is the same as if I had the cross section like this. Right. But when we have this like this, the air is distributed over a much larger area. As you can see, is if I strike the object here and I go straight down, it's going to rotate. So the energy is being transferred horizontal to the direction of motion as opposed to just pushing back. So it has nothing to do with parting the air. It has to do with redirecting the force of the air resistance sort of inward like this as opposed to against the direction of motion.